Okay, so we're going to try to wrap up this factoring. Yesterday I didn't give you any where you had to factor with the number in front with undoing FOIL, but remember you just have to think a little bit more. And I'm going to show you how I do this, and hopefully it'll make sense. If you have another method that you do, by all means, do it, okay? But a student of mine called this a rainbow method because step one, I tried to give you some steps here. Multiply the first and the last number together. So if I draw a line here, 3 times -3 is -9. And so a student a long time ago called this a rainbow method because it looks like I'm drawing a rainbow every time. And that helps us now come up with our step 2. Now it's the same question as yesterday when there's no number in front, but now you say what multiplies to give me this number that adds or subtracts to give me this number. And again, this sign determines it. So come up with numbers that multiply to give you that number at the top of the rainbow and add or subtract to give you the number in the middle. So we want to say what multiplies to give me -9 that subtracts to give me -8. Well, it has to be -9 and +1, right? -9 times 1 is -9. -9 plus 1 is -8. And now step 3, replace the middle number with those two numbers. So all I have to do is put the m with it. So basically I'm rewriting this term as these two terms. So I haven't really changed the problem, I've just rewrote it. And then, so we're just rewriting this, so we bring down the other numbers because we haven't changed those. So this problem is still equal to this. And now we have set up a factor by grouping problem. So now I can group these two together and I can factor out a 3m, and I'm left with m minus 3. And if I group these two together, there's nothing to factor out, but I could factor out a 1, and I would be left with m minus 3. And I want these two to be the same because I'm going to factor those out, and I would be left with 3m plus 1. It doesn't matter which order that's in as long as you have an m minus 3 and a 3m plus 1. If you learned how to factor these using a different method, by all means use that, but this is how I do it, the rainbow method. So let's practice a couple. So what about this one? There's a number in front, there's no GCF, so I'm going to do an upside down rainbow this time. 2 times -18 is -36. So then just like normal factoring, to me the hardest part is coming up with the two numbers. What multiplies to give me -36 that subtracts to give me -9. What, 12 and 3? 12 times 3 is 36. And I want a -9, so that would be -12 and +3. It also doesn't matter which order you do this in. I'm going to do it a certain way on purpose this time. So I'm going to say plus 3y minus 12y. I left the 2y. And I'm going to bring down the -18. And I grouped it this way on purpose to show you what happens with the negatives. But on this one, what can I factor out of that? I can only factor out a y, and I'd be left with 2y plus 3. And then over here, I need that to be positive, so I need to factor out a -6. And I would be left with positive 2y plus 3. And if these are the same, that's how you know you did it right or that it's factorable, because I can take those out and put together what's left, y minus 6. And then that's it. What else I like about this method, when I was taught to factor, I wasn't taught this method, I was just taught to guess and check. And sometimes you guess and check a lot. But look on this one. 3 times 1 is 3. So I'm trying to think of things that multiply to give me 3, that add to give me -2. Well, 3 is a prime number, so the only thing that multiplies to give me 3 is 1 and 3. But can I add 1 and 3 together to get a -2 in the middle? And the answer is no, which means that there is nothing that I can rewrite this as to factor it, which means it's not factorable, right? So we like to say, either you say not factorable, or you can say prime, because that means there's nothing you can factor it into. So using the rainbow method, you can figure that out. So those are the methods that we have to factor. So now we can do what this lesson's really about, which is solving quadratics. So remember, the zero product property says for any real numbers a and b, if a times b equals 0, the only way you can multiply to get 0 is if either a is equal to 0 or b is equal to 0, or both. Which means this is why we factor. If you can factor these into multiplication, then you can set each one equal to 0, and you can get the answers, like x equals -3 or x equals 5. Those are the x-intercepts that we were finding when we were graphing last week. But now we don't have to graph, we can just solve it, okay? You can only do if it's equal to 0, right? If a times b equals 2, that doesn't mean that one of the numbers is 2. So all the types of factoring are going to be together. So now you have to kind of put it together. So if I was going to factor this, there's no number in front, there's no GCF. So I'm just going to make my parentheses here, and I'm going to say x and x, and I'm going to say what multiplies to give me 45, that subtracts to give me 4. I believe it's going to be 9 and 5. And since I want a positive 4, it has to be a positive 9 and a negative 5, because 9 minus 5 is 4. And I know that most of you aren't going to show this step every time, but I'm going to do it at least a couple times. The zero product property says because this is multiplication, I can break it apart. And then all I do is subtract that over. So x equals -9 and x equals 5. And I don't know about you, but I would much rather do it this way than to graph it. Sometimes you have other options here. So I'm going to show you 2 ways to do number 2, okay? If we were going to factor number 2, we would get it equal to 0, right? And then that's just 2 perfect squares. So that's the difference of 2 squares. What's the 121 is the perfect square of 11. And remember, to get nothing in the middle, one has to be a positive and one has to be a negative, which means you're going to get x equals -11 and x equals +11. You could also use the square root property here. So go back to the beginning. You could also just take the square root of both sides. But remember, when you take the square root of both sides of an equation, it's plus or minus 11. So you get the same answer. That only works if there's no like x to the first power. Okay? What about 13? Again, we kind of have options here of what to do depending on which way you did the last one. I like the square root property, which means when I see that there's no x in the middle, I don't factor. I do the square root, because I could subtract 13. 17 minus 13 is 4. So I can take the square root of both sides. But remember, it's not just +2. It's positive or -2. You could get the same thing if you subtract it the other way. If you subtract 17 the other way, you would get this, which factors into x minus 2 and x plus 2, which still gives you positive and -2. What about this guy? First thing I'm going to do is I'm going to get it equal to 0, okay? Because we can't factor if we don't have it equal to 0. So I'm going to add 12 to the other side. These are really big numbers. And so one thing I want you to look for is GCF, right? None of the other ones we've done have had a GCF, but this one does. It actually has a GCF of 12. Since it's equal to 0, I don't even just have to take it out. I can just divide everything by 12, and that doesn't change my problem. You could also factor it out if you want and just keep it out front. But when it's equal to 0, you can just divide it out. Oh, I can't divide 75 by 12. Oh. Okay, I thought 12 was a GCF, but hopefully you caught my mistake that it's not the GCF. So what is the GCF then? Only 3? 75? Yeah, okay. So I'm going to divide by 3. I don't want a decimal in my problem, so don't divide by something that's not the GCF. So that would give me 25x squared minus 20x plus 4 equals 0. So I'm not one to notice this very often. This is one of those special cases because it's a difference of 2 squares. I probably wouldn't have noticed that, and I would have done this. 25 times 4 is 100. Rainbow method, and try to think of numbers that multiply to give me 100, that add to give me 20. And it's just 10 and 10, right? So that would be 10x and 10x. But because it's a minus 20, it would be a negative and a negative. And then I bring down my plus 4, I bring down my 25x squared, and I would just factor this. I would factor out a 5x, and I would get 5x minus 2. Over here, my signs are switched, so I would factor out a negative 2 in order to get positive 5x minus 2. So I get 5x minus 2 and 5x minus 2. This is a special type of thing because it's a perfect square and a perfect square in the middle, but it's the same sign in the middle, not different. So if you notice that, you can do less work than I did. I tend to not notice that. But what I do notice is that since the same one twice, I'm only going to have one answer, right? So I'll show my work. So I would add 2, and I would divide by 5, and I would get 2/5. This is an answer that would be hard to get from a graph because it's a decimal, it's a fraction. But because we only get one answer, remember what that means. That means that that point is going to be our vertex right there, right, on our graph. Where's my time at? 11 minutes. Okay. So then the last one here is kind of a throwback to the one that we did before, writing a quadratic in standard form. So I want you to think about working backwards now. If this is the 0, could you write the factors so that you could multiply this together? And we'll start with this one in class.